Ventilation in high-rise multi-unit residential buildings is essential and important to ensure a healthy indoor environment. The strategy has always been to bring in outside air into each residential suite, while at the same time exhausting a similar amount of air to the outside. However, in the age of rising energy conservation awareness and rising energy prices, this process proved to be inefficient. And that's because while you're exhausting air from inside your suite, that air that being thrown technically or basically into the outside is already heated and cooled by the mechanical systems in your suite. And then you're bringing in outside air that need to be heated again or cooled again to make sure it doesn't have an impact on the comfort and the temperature inside your suite. For this reason, energy recovery ventilation system was developed. And the way it works, very simple concept. You're using the exhaust air that's leaving your living space or your suite to preheat and humidify the outside air coming into your suite in the winter time, or you use it to pre-cool and dehumidify the air that's coming from the outside into your suite in the summertime. This ventilation energy recovery strategy was first used on central ventilation systems. It relies on a big air handling unit on the roof of the building that delivers large amount or volume of outside air into the corridor. However, this system again proved to be inefficient and inconsistent in bringing in the required amount of outside air into the suite. For all those reasons, Tridel decided to move away from centralized ventilation systems and instead start using decentralized in-suite ventilation systems. So this here is an inside view of the integrated fan coil unit. And the reason why we call it integrated because the ERV or energy recovery core is integrated inside the fan coil unit. The way this system works, outside air comes from this compartment here inside the ERV core and leaves the core from this end here into this compartment. While the exhaust air comes from the washroom area, comes through this compartment here and enters the core from this end and leaves from the opposite side of the ERV core. And then the exhaust air enters a side duct here on the side of the unit and makes its way all the way to the outside. Now what happens inside the core is that both air streams, even though they cross each other inside the core, they don't physically touch each other. But what happens is energy and humidity transfers from one air stream to the other. And one thing unique about the dPoint ERV core that it won't allow any contaminants or anything in the air coming from the outside to transfer or cross to the air leaving the suite. And now we will be looking at a standalone ERV because it's separate from the in-suite heating and ventilation system. Let's have a look. It's an insulated box with two motors installed in it, one for the exhaust air and a motor for the outside fresh air. This is the dPoint ERV core. So fresh air comes from this side through the filter into the core and exits from this side. The washroom area exhaust air comes from this side into the core and exits here to the outside of the building. And while the outside air is going through the core this way and the exhaust air going through the core this way, heat transfers from one airstream to the other. And now let's have a closer look at the dPoint core. As you can see, it's very easy to remove the core from inside the fan coil unit. The core is also easy to clean with running tap water. When you're done, just rinse it to get rid of the excess water and then put it back in the fan coil unit.